Question number 30. A positive charge Q is deposited on the surface of a small sphere. The dotted lines represent the equipotential. Okay, what is equipotential? Equipotential means the potentials along the dotted lines will be the same. Okay, whether you move from P to, let us say this is Q. Okay, it doesn't, not Q. Let us say it is some A. Okay, the potential here is the one and the same. Similarly, potential along all these points are the one and the same. Okay. Now, a small point charge is moved from point P closer to the sphere on three different paths. So, you are moving from P to this point. Let me call this as, what did we call? VA called, right? Let me call this as B. Let me call this as C, and this is D over here. The work done along each path is Wx, Wy, and Wz. Okay. What is the correct comparison of Wx, Wy, and Wz? Okay. So, what we need to do is, see, since you move a longer path over here, definitely this work done Wx, okay, will be larger than this and this. Okay, why? Because you have to go against this plus Q charge, right? So therefore, definitely this is larger. Okay, but if you look at this Y and Z over here, they are equal distances. The potential differences here are same. Why potential difference is important? Because you know work done is given by Q into delta V, or V1 minus V2 over here. If I consider this as your V1 and this as V2, V1 minus V2 here will be the same for Y and Z, and as a result of it, Wy will be equal to Wz. The work done by the particle in moving along this path is the same as work done moving along this path. You may think of, see, you are describing only quarter circle here, half a circle over there. But what you need to do is not quarter and half circle. You need to look only at these 2 points over here. Why? Because if you start moving along this point, there is no work done along the dotted lines over here. Why? The reason is because potential is same. See, the potential at this point, let us say this is a VO1 and the potential at this point is VO2. Both are the same potentials because it's an equipotential line. So when I say work done in moving a charge from this point to this point, it is Q into VO1 minus VO2, Q into VO1 minus VO2. Now VO1 and VO2 are the same, so therefore it will be identical. So this becomes 0 over here. No work is done when a charge particle moves along the equipotential surface. When it moves in between the equipotential surfaces, then only a work is being done. So the right answer would be Wx. It takes a larger distance, more work done is greater than Wy is equal to Wz. Now let us look at the options here. Wx is greater than Wy is equal to Wz. So the answer B is a right option.